Welcome back to the second part of the session. It's a pleasure to have Ella Peltonen to talk us about car a little bit more.
Yes. Thank you.
Thank you.
A little bit more about the cars. So, the vehicles in general are given as one vertical use case for edge computing. I have been working some time now with edge AI, edge intelligence, edge stuff, but then like a little bit over a year ago I started a new position in software research in a lab where I got kind of like a new topic, so now I work with the cars. But edge and cars are related, so today my goal is to explain why and what kind of things we need to consider designing things for intelligent cars in intelligent computing environment.
Can you take a mic?
Okay, this is not this.
Or a little bit closer.
This is not like okay. I can take the other mic.
Oh, you want this mic?
Working.
Sure.
Maybe it was just too far away. Maybe just.
Yeah, but I don't have anything here. If I put it here, it will be
No.
okay. I will take the other mic.
I'm sorry.
Sorry. Technical.
Much better.
Is this is better? Good. Yes, good. I usually prefer to use those, but anyway. So anyway, you already heard about Mercedes talk. The cars are more and more software products nowadays. Nowadays cars, this new car you get in the market today, 100 million lines, 100 million lines minimum of code. So that means that there is multiple, of course, these easy use or electric computing units, sensors doing certain things, so it's a distributed system of its own. And all the systems, all the easy use are combined with the CAN thing, so there is a communication channel, what's happening inside a car. And there is a huge computational capacity, there is a huge networking capacity already, but there is also a huge amount of data. And for me, doing my degree back in Helsinki in the big data analytics, the cars are actually a very nice source of data if you can get access to all of the data. But the data is also so huge that processing the data somewhere on the cloud side requires huge networking capabilities. And I would rare to kind of say that it's not possible to deliver all the data even nowadays, and less in the future to any of the cloud environments, just because the data is coming so huge. Different sensors, more sensors are coming, and the collaboration, as Rose mentioned in her talk, collaboration between the different sensors is like a black box. So things happen inside, and we just trust it happens. Most of the people, they know the infotainment system, so you have a screen where you can have apps, Spotify, Netflix running, but then there is other computers which are focusing on only doing certain very specific tasks. And that kind of makes it complicated, because manufacturers have been adding capabilities. Oh, you need a computer for brakes. There is a sensor for braking system. Oh, we need to get the computer for that. And that's a computer that does one thing, which is the managing the braking system, collecting data from that sensors or related sensors, and sending the data that the braking status is this. Then you have the fuel consumption sensors. You have one computer managing the fuel consumption, and then you know how much fuel you have left or electricity is left, and things like that happen. So the system is built very differently than anything else, because it's originally a hardware product, of course. It's a car. And the traditional intelligence which is added to the car focused on the internal functions in a car. How to make the driving safe, how to add automation, lidars to figure out how far is the next car, braking system, automatic braking systems, automatic functions on keeping you in the road, line tracking. Those have been internal functions, and all cars currently are actually very good at this. So they can keep you on the line. They are already semi-automatic. If you're driving on a highway, You have all the cruise controls, you have all the gliders, you have all the mechanics and related software to keep you on track. And that consists on the 100 million lines of code already. So now we are adding more. We are adding more software, more applications, more safety features, communication with other cars, communication with the environment and weather cameras. And that means that we are adding more and more software, more and more computational capacity in a car. So the direction we can see where the cars are kind of going is to become smartphones, where you can install anything you want, multi-purpose devices that can do many other things too, not only driving and getting you from one place to another place, to A to B. There was a nice talk, I think a Darksville seminar a couple of years ago, where a guy from Nissan told that they have this educational aspect. So you have kids in your car, and usually you just give them a tablet or something to do, and if they are asking, Daddy, Mommy, where we are there, when is the break? And they have a solution where they show for the kids like educational things around where they were driving. That okay, there is something you can see on the left-hand side, and this is the old-fashioned temple from ancient Greek, and now you see the temple. And did you know that people live like that in that temple area? And they did these kind of rituals, and so you can add experiences in your car and you're driving. And someone claimed to me that's already a reality in the US because of the current driving control solutions. People are pretty much putting in auto cruise control and automatic cars, of course. And then they take a smartphone and watch Netflix then when they are driving on the highway. I wouldn't consider that very safe. So the direction is that the cars are much more than just devices to take you from A to B. And the weather. So most of the self-driving cars for now have been tested, first in sunny California, then in Germany, some other places where you have lines, you have cruise, you have a certain infrastructure, which is upkeep. The weather is usually nice. Then you come to Finland, you drive in conditions like this. So it's do you tell people that you cannot go to drive because the weather? Who would not drive in this weather? I have to, because this is half a year of my life. I cannot close my classes or tell my students go home, because everybody goes to school, everybody goes to everywhere, even if it's a snowstorm coming. Picture not taken by me, my husband was sitting next to me. So you need to focus, really focus. But the good thing is that even if you don't see the lines, this is, by the way, a highway. did I mention? This is a highway, so there is one direction, two, and there is this other parts coming, you kind of like see. So you don't see the lines, there is no coming, and but you can drive because you have the human cognition. You can take the smallest hints in the environment. Where are you going? And I haven't had any snow-related problems in my life, and I drive every day. Okay, we do have problems with the snow, but put an AI in this environment. And by the way, when it's snowing enough, your network coverage is very bad, so you don't even have a cloud support. Of course, some people tell me that the Finnish people don't need the cars, then maybe they are just not having the cars in the future. But anyway, a lot of the features enabled by software certainly coming what we need, the software-defined vehicle. So cars are already, they have a lot of software, but are they defined by the software? Not yet. Many people know about the API, how to make the different pieces to communicate with each other, but it's actually a lot more social communication between other cars from other car companies. So if you have a Mercedes car, I have a BMW car, but they don't communicate. we have a problem. Because if you're driving in the conditions, I need to stop immediately and I want to deliver you a message that there is an accident on the road. But I cannot do that because I can only inform other BOP cars. So, and you cannot force people to get cars from one company only. So we need platforms that can share information, that can share communication resources together. Electrification, automation, connectivity. Electrification is actually one very nice and important thing here because the battery life will become an issue. Not just because you optimize your driving road and speed and stuff, but more you add computing, inference of huge AI algorithms in your machines, more your machines need electricity to actually drive your car. And then you're running out of the battery because your algorithm had a bug. So, not great ideas. But that's what we expect. We expect everything to be easy, automatic, personalized, safe, effortless. These are things we expect from kind of IT experience. You get a new tool, get a new car. And one thing we are, my background is purpose computing and data analytics. Why I work in software? Okay. Long story short, software is a lot of data analytics. Understanding what's happening in the software, a lot to do with the modeling, simulation, real-world testing, understanding the whole life cycle. People are talking they want to have a continuous integration in cars. But you have continuous agile developments in cars, like in smartphones. In smartphones, something crashes, it's a little headache. You have a car, you want to go at work a very early morning, nothing works because it says that there is a safety critical important update and you need to update the system and it takes half an hour. So you are late at work for that reason. So managing the software, how tested it needs to be. Because we are used as software developers, we used to have everything very early on and we test in practice and develop, continuous development, testing stuff. So, but it becomes very hard when you have safety critical consumer systems in the end of the other loop. And there's life cycle, 20 years, same mentioned by the Rose, 20 years. How many have had the same computer 20 years? That's a very good question. I personally, haven't even had a car for 20 years, but that's the expectation. You should have a lifetime for 20 years. For smartphone, it's 2 years or 3. So these are expensive devices, and they become more and more expensive the more you add their features. So people get a new car when they really need it, but a lot of people actually get a one car and they hope that it lasts like as long as possible. Because it's an important device and it's an investment also. But the software updates, do people really install them? If we force people to install them, is it affecting the usefulness of the cars? And that's a critical question, needs to be solved. More you put the software in your car, more you really need to care about the software in the future. And this is also about testing the software. There's a lot of safety testing for the structure of the actual car, the metallic parts. You do the crash test. But do you do the crash test for the software? Not really. And what happens if the car is in a crash, actual accident? What happens to software after that? Can they inform emergency services automatically? Hopefully. Software-defined vehicles. We discussed on the Monday about this, and I got this joke. Again, would you download a car? The answer is yes. You need to download your car. In the future, your car is useless without the software, and that causes a lot of problems. You need to keep it updated, download it, and you need to have a network. And downloading huge software packages over mobile network Because do you have a Wi-Fi in your car? Likely not. Depends on the operating. Maybe we will have an operating service for specifically for cars in the future to get the enough download power to run the huge updates. Some hope connectivity capabilities increasing all the time. I'm not a big fan of the 5G. None of the Oulu people are, because we are already developing 6G. This is why the car has 6G. It's a 6G car. Don't ask me what's the 6G, I don't know yet. It's coming, project is not ready yet. But yeah, we have 2 of these cars, Toyota cars. I'm getting more cars if you have deals for manufacturers. Representative research is in research infrastructure. So, intelligence in general, here in this case, we are not aiming for fully automatic cars. This is important. We are aiming for increasing the intelligent capabilities that can be used for applications like self-driving. So the self-driving itself is not the goal. The goal is to have capabilities like connectivity, intelligent, basically CPU, GPU, power, and orchestrated software environment where we can run these things, and then the software in there, so that we can enable and enable capabilities like self-driving. But it's an application environment. And what would be great, it would be open sourced, because then third-party developers would take it. Okay, I have an idea. What else the car be than just a driving vehicle? Maybe we can collect environmental data. Maybe when we can collect information about the road infrastructure, we can collect weather data with the cars. A lot of crowd-sensing opportunities with the cars because they are everywhere. I don't have a lot of time, but let's go quickly to the edge stuff. So why we need edge? Okay, good. Cloud computing, far away. Edge, something you have a little bit closer. I don't like to talk only about the edge or cloud. I talk about the continuum. Dustar is not here. Shahram Dustar, when we had the Duxtool seminar about edge, cloud, intelligence, and continuum, and there's a nice paper based on that you can read. Anyway, this basically means if you have a smartphone, smartwatch when you are driving, other devices in your local environment, you can take all and connect and talk with each other. You have other cars, you can connect and talk with the other cars. You have road infrastructure, edge infrastructure, you can talk and share tasks with all of those. Why we need edge? And this was the question asked after last presentation. What happens when you lost cloud connectivity? And do you need cloud? And my answer is yes and no. The goal is that if here we have like a full everything on the car, and there we have operating on the edge, or on the cloud, and there is different levels of edge. The goal is that something can happen inside the car where of course we do have unlimited data available, just the latest data, we have limited knowledge, but we are very independent for any networking capabilities, and we can do very quick local decisions. Contradiction to cloud, where we have all the data you can imagine, but you are far away. And this should be dynamic. So whenever the situation defines that we need quick decisions, we do it locally. If we have no network, we do it locally because we have no options, or we reach for edge services available. And if we have something that requires huge computational tasks, we do it to the cloud. But this decision where to compute should be dependent on, of course, the resources available, resources being your electricity left, or your gasoline pretty much left, network availability, resource availability, computing resource availability, data availability, how critical is the task, what is the task in general, is it a life-saving task, is it something nice to know task, how much time we can wait for it. Life-saving tasks have to be computed in less than a millisecond because they are life-saving. So a lot of dependent what we have and where we should compute, and that should be dynamic decision based on the time and place, because also the place matters in edge computing. Do you have edge capabilities? Can I have access to edge capabilities? Where is the freaking edge at all? Edge people can hopefully in the future answer where's my edge type of questions. I have the citations here if you're interested in the details. The papers here are pretty general, in edge computing in general, but I kind of like to bring this back to vehicular perspective. If we define something that the future edge computing has to be scalable, okay, we have millions of cars, easy to scale. Then you scale it the same edge to smartphones and human sensing devices to define whether the person who is driving is safe to drive, not drunk. Trustworthiness, sustainability, equal accessibility, accessibility especially if you have multiple manufacturers of the cars, multiple software providers, how they communicate with each other. Someone who has a 10 years old car, do they have access to the same safety critical systems than those who get a new car today? And how you handle the 20 years of legacy code in the future? When you have all the old cars and the new cars, and you should keep them on the same standard, not forcing people to get a new car if there is no option. And putting a car in this picture is a little bit hard, because cars are safety critical in essence, and it's a very hard to test anything with the car. It's very hard. It's well regulated, of course, but also it's a safety critical. But what we like to do is to create an environment where we have communication structures on both horizontal level, car to car, vehicle to vehicle, and this is very related to space and time, and space-time. Maybe not.
Black holes.
and because the vehicles which are in the same location at the same time, they have the best possible capabilities to share information. The example I often use is we have the reindeers, wild reindeers running around in Finland, and you cannot kill a reindeer. It doesn't harm you, but it harms the reindeer to kill it. And if you have a reindeer accident on the road, usually you can continue driving by yourself, but there is a dead reindeer on the road, and that can be a hazard. So it's good to notify other road users. And usually you can notify those coming back by putting a little square, red square on the road. But how you notify people on the upcoming traffic that there is a dead reindeer on the road? So a lot of different use cases for horizontal community. Then the humans in the loop. What happens inside a car? Inside a car is a computational environment. It's a small little software-defined network in a car. Your smartphone can tell you, how did you sleep last night? Are you good to drive today? Are you good at working as a backup person? Or if you have more of those self-automated functionalities going on, something happens, the car doesn't know what to do, how they inform person that now you need to take control over the car. Because stopping a car in the middle of the highway in the snowstorm is not an option. You cannot stop the car. Because there are 10 cars on the back of you and crashing you. And then on the cloud edge stuff, we go all the way back to edge computing, large-scale data analytics. There are a lot of options for a lot of things, but we need to define all of this, of course. I'm running out of time already. Couple of research questions we are discussing on my team. So I'm leading this small, together with the one full professor, we are leading the small research group in software-defined vehicles in Oulu. We consider this will be a huge research area. This is not solved in the next EU project. this is not solved in next 10 years, it will take 15 last more. But it's understandable if one car's life cycle is 20 years. So I'm especially interested in the communication and computing aspects, how to share communication, computing, how to share the resources, where to compute, what to compute, and how, considering this is an environment where the cars are moving all the time, and they can change the direction wherever they want. It's like an ad hoc network without any control of where the cars are going. And how to put in efficient AI and machine learning in this picture. And how to share the machine learning tasks, because this is also a distributed environment. And then privacy, security, and how to do the software development in this picture. I'm just checking what I have time to show you. We did a one reference architecture paper already. Reference architectures in this format, where you have pictures, are not very good. You need a software to show that your reference architecture has any good to do. That's why the name of the paper was the worst, because we don't have the software yet. But it's coming. Wait for it. Then we have the Kuxa project. This is an Eclipse project. It started from the Oulu. So the Kuxa is a communication, data sharing and communication platform or protocol for delivering car data to the cloud, or maybe to the edge, because it runs on the Kubernetes, and you can put the Kubernetes and Dockers on the edge too, so you can do that on the edge, pretty much. My students have done it, but we don't have a publication yet. So if you're interested in how to get the data out of car, Kuxa is one option. If you want to more details, I have to take a quick picture or remember the name of Kuxa, because my students are very much working with the platform. It's now some 4 years old, but it's kind of nice. Good. This is what we aim to do. I'm very open and happy for all kind of collaboration in the future, whether it's in machine learning or edge computing, or putting together more vehicles and resources, because there is not so many labs who have cars, and those who have usually, we have only Toyota cars for now. We used to have a Volvo cars, but not anymore. I'm waiting for more cars, waiting more resource money. But unfortunately, it's like you get the funding, and then you get the funding for infrastructure, and you get the one car with the funding for infrastructure. Why we need, by the way, new cars, real cars? Why just not simulate? Because we want to drive them in real environment. Well, world is, there is a lot of things, it's infinite amount of things that can happen in the real life. If we want to simulate real world, we need to have data from the real world. That's why actually also other research units use the cars. They have the data collection always on. Other researchers know that there is a data collection always on. So we get the data all the time from that. And we are building the simulation environment next, so that we can simulate accidents and things like that on the software perspective. Good, that's it. I skipped some technical stuff, but just go to read my papers if you are interested in technical stuff.
Good, thank you. I think I have time for a couple of questions. Alexander?
I have the following question. I mean, of course, it's very nice to hear about all these open platforms, communication, that we can all contribute to this. But if I look at the automotive sector overall and software development there, I think this is the most closed software development environment. It's all being overly protected. And to be honest, even at the moment when all these marketplaces were created and things, there was no easy way even to inject into the entertainment systems, which apparently probably will be as safe as possible. So, and for me, to be honest, I would love to kind of jump in and say, let's develop something together. but the barrier seems to be so high, especially if you're not part of already, a company which develops something, that for more independent researchers feels like, this will be probably the biggest barrier, not some technical issues. Even if there are technical problems here, so I'm curious about what's the experience, is penetrating this barrier, even if you see any improvements in that direction.
Yeah, that's true. We have some European initiatives coming on the area, hopefully. Hopefully it will go through and we get funding and start like a real project on open source development on Vehicular so that we can actually have something for people to contribute. Booksa is nice because you only need an OBD reader and you need a Raspberry Pi or a laptop on your computer to run it. So you can pretty much install any card because all the cards have OBD ports. Because that's the standard what they do in service. If you get your car to the service, then they get the error codes through the OBD reader and every other information. So that's the same channel. So you can do that with any car. It's usually under the bench of the driver, under the wheel. But yeah, that's a big problem. And one thing is getting the data sets. So there is no open data sets. Everything is either simulated or so much anonymized you don't need to do anything with it. So that's why we are heavily now creating new data sets if we can. Of course we want to do our research first and then web publish. But yeah, hopefully there's more in the future.
More questions? Well, if not, I have one actually. So if you look at Waymo, they're already operating in San Francisco and Phoenix, driverless. Did they already solve some of the problems you were mentioning, or do you think they took some shortcuts? What do you think about it?
The driverless operations in those environments, usually they have very good maps and they have very good remote control. So they have a network which is very strong and they have someone who is monitoring as a remote driver because you always need to have a backup. And then you can remote control fleets, but trust is kind of interesting issue. Then you trust someone you've never met to drive your car remotely for you. If there is a thing where it fails. And of course, it depends on the environment where you are, how easily you can stop if everything fails. So then you need to have always the backup of the backup. So if one system doesn't work, then what's the next system to go? And the final is usually human. And if it's not the human in a car, it's usually the human in the remote box. But then you need a very good remote control. I know they do that. The Nissan has a very nice LiDAR-based maps where they can drive automatically and remote control even in the environments where there is no markings in the roads or no lines in different environments. Very, very nice works, but it's if you consider the whole world, and the world is not perfect. In certain places it may work, but it needs a lot of background data and maps. And by the way, when you come to the Arctic Circle, we don't have accurate maps because we have a little magnetic field issues there. Yes?
Good question. You talked about a car trying to figure out its environment. Would you anticipate in the future cars to become social? Because families, have multiple cars, they go in groups, friends have cars, they go in groups. Would you anticipate cars to become social so they can actually share information?
Yep.
And tell somebody that the traffic is high, or there's a hailstorm, or there's been an accident, where you don't have to depend on maps, you depend on other information. So
yeah, that would be great.
Socially conscious car, would that happen?
Hopefully, I'd like to see it happen. But it means that the different brands of cars need to communicate together and share information together.
Well, it already happens now with people use WhatsApp to communicate on the cars. Right? They'll say, oh, I'm stuck here, I'm stuck there. They're already using apps that are on the phone. Right? Technically, you can build a social network with an existing app on the phone.
Yeah, there is interesting human. They need to be car-to-car social network and social behavior, maybe modeled by some animal behavior. Because what happened, they put on this social media on airplanes, where they had like screens and you could chat and send some emojis to anyone in the same plane based on the number of your seat. And people started harassing other people immediately. and sending, oh, there is a nice lady in the row 30. So
But what I meant was
people are,
like a
put,
WhatsApp
if you
group.
leave the people out of the picture, and you know what people do when they're driving to someone else. So leave people out and construct a social behavior between cars only. Of course, cars have no emotion, so our social behavior is driven by emotional need to be social. Cars, social behavior could be driven by a common task. Then you talk about the vehicle-to-vehicle communication and things like that. So there could be an underlying kind of construction of social behavior, because there's a lot of studies on social behavior without emotional drivers, for example in ants and stuff. So yes.
So what I meant was, there's the sort of car-to-car social behavior. Also, you can imagine having a WhatsApp kind of application, where cars are, using that to be able to share information. But the human is the first app. Human is part of the app. The future could be human can be taken out of the loop, and then the car becomes one of the users of the app. So that's also possible. You already have the apps. You have the technology.
Yeah, there's the ad hoc network side. There is a lot of biological modeling on that direction. So yes.
Good. If there's no more questions, I think we can thank the speaker again. So we will meet at 1 o'clock, where the bus will be waiting for us to go to the social excursion. So you have 50 minutes for lunch.
Okay. Are you here tomorrow? Yeah. Yeah. Okay. See you around.